Welcome to this sixth video of lesson Parallel Lines from Standard 9th Mathematics Part 2. In previous videos we have seen the if the two lines are parallel and it is intersected by a transversal, then the pair of corresponding angles are congruent, alternate angles are congruent, and interior angles are supplementary. Okay, and we have proved this, and we have solved sums based on this, as well as we have proved and then some property of a triangle, which is one of the most important theorem, how to prove that theorem. Now in this video we are going to see the tests of parallel lines. So when a transversal intersect two lines, and if we want to decide whether these two lines are parallel or not, how can we decide? Again, we have to take help of that pairs of corresponding angles, alternate angles, or interior angles. If interior angles are supplementary, then the lines are parallel. If corresponding angles are congruent, then the lines are parallel. If alternate angles are congruent, then the lines are parallel. So these are the tests for deciding whether the two given lines are parallel or not. So we are going to prove this test one after the other. So let's read the first test which we are going to prove. It's interior angles test. What is the statement tells? As I told you, that if the interior angles formed by a transversal of two distinct lines, okay, are supplementary. So there are two distinct lines, different lines, and there is a transversal and angles formed by this transversal, these interior angles, if they are supplementary, then the two lines are parallel. Okay. Now to prove these two lines are parallel, we have to draw a figure of two parallel lines. Okay. Say this line A, I can say L, M, N. And as we required to get interior angles, let's take the points on this line. So this can be say AB, C, D. This transversal we can get it as PQ. Say ABCD and say XY is their transversal. Okay, and then it is intersecting at point P and Q. So we have to prove that these two, suppose this is first angle and this is the another angle, and if these are supplementary, we have to prove these two lines are parallel. So what can be given here? In given, we cannot say that these two lines are parallel. This will come as to prove. So here we will say line XY is a transversal of two distinct lines, AB and CD, AB and CD, such that the pair of interior angles, that is angle BPQ, such that angle BPQ plus angle PQD, this is equal to 180 degree. They are supplementary, means their sum is 180 degree. And if it is so, then we have to prove that line AB is parallel to line CD. This is our to prove part. Okay. Now here, as we have not any supportive statement for this, we need to prove this theorem or this statement by indirect method, in which we will assume whatever to prove is wrong. Okay, so we will assume that these two lines are not parallel. If they are not parallel, what will happen? As they are in the same plane, they will intersect somewhere. So now this line extending and intersecting at some point, here in this figure we cannot show. So let's draw one similar figure as per our assumption that these two lines are intersecting each other. Say at point, whatever point we can give it. Let's draw first these two lines and give the same name. So this line is A, okay, here it is say B, this line is C, this line is D, this point is P, this is Q, and this is X, and this is Y. Okay, so all the points names are similar, only the thing, instead of here we have drawn parallel, we have drawn two such lines that they will intersect at some point. Say you can take it as say point T. Okay, so we will start our proof, or let's complete how to prove. So we are going to assume that if it is not parallel, let's repeat. Okay, now here this is the angle number 1 and this is angle number 2. Here also this is angle number 1 and this is the angle number 2. Now because these two lines are intersecting, we got here third angle, PTQ. Okay, now as per this, know that just now we have proved in the previous video that some of these angles in the triangle are 180. So here we can say angle 1 plus angle 2 plus angle 3 is equal to 180 degree. But what is given to us? But angle 1 and 2, they are supplementary. It's given their sum is angle 1 plus 2 is given 180 degree. Okay, so it means that sum of these three angles and sum of these two angles is same 180 degree. So therefore angle 1 plus angle 2 plus angle 3 is equal to angle 1 plus angle 2. These two sums are equal. They are equal to 180 degree. What does it mean? Suppose we cancel this angle 1 and 2 from both sides. What is angle number 3? If we will get it equal to 0. Okay. So first of all, this cannot be 0 because it's a triangle. So here something contradiction we are getting. But how can we prove? So if angle 3 is 0, what does it mean? These two rays. So angle PTD. So what is the name of the angle? Third angle is angle PTD, or you can take Q, PTQ. We will get this 0. What does it mean? That vertex P. What are the two rays? These two rays are TP and TQ. Okay. Suppose I am trying to explain you here in this figure. Suppose this is the point P and here one ray is going towards P and another ray is going towards to Q. So this is PTQ. I am drawing this angle in this way. Just to, when this ray TQ is the basic ray and this is the another ray, okay, having same vertex, we get this angle. Union of these two rays, we get this angle. And this measurement between this is called, we call this as, and this is the angle. Now this angle is going to be more than 0 degree. It is, value is something positive, correct? Okay. So now, in which case it is 0. So this, when this is 0, but if this is your ray TQ, and now suppose this ray TP is not some other ray, but it is, suppose it is overlapping on this only. So if this ray TP is same ray, so this is ray TP. So if these two rays TQ and TP, if they are coinciding each other, if they are overlapping to each other, in that case, that this angle 0, this theta, this angle can be 0 degree. Otherwise here this theta is angle which is more than 0 degree. Correct? So if we find this angle is 0 degree, it means line PT and line QT, these two lines are coincident to each other. They are overlapping on each other. But what is this line PT? Line PT and line AB, it is one and the same. If we find PT and QT, these two lines are coincident, then PT means what? It is AB. It's going to be AB. And what is QT? QT and CD. So these two lines are coincident. If these two lines are coincident, they are overlapping on each other because this angle is 0. These two angles are also coincident. But are this coinciding line, this overlapping line? No. What is given to us? That XY is a transfer of two distinct lines, AB and CD. So AB and CD are not one and the same line, they are two different lines. So here we find our contradiction. And why this contradiction we got? Because of our assumption, we are going to assume that these two lines are not parallel, so they are going to intersect. So that's why our assumption is wrong, and hence we can prove that AB is parallel to CD is the correct one. Okay. So in this way we can prove this statement. So let's prove this. Okay. So let it be a part over here. When I will need to cancel, we can cancel this part. Okay. So our proof part, we can start like, let's assume that line AB and CD are not parallel. Okay, therefore they can meet at point, say, T. Same as let's take T. Okay, therefore therefore in triangle PQT, we got a triangle PQT where sum of this three angle is 180 degree. What is this first angle? P. P should be written in center. So what are the two letters remaining? QT. So QPT plus angle Q, that is PQT. So Q is in the center, PT here, plus angle T. T means left and right, it should be P and Q. This is going to be 180 degree. The reason is angle sum property. Okay, now let me have this part over here, so I can write this reasoning over here. This is angle sum property of a triangle. So statement number 1. And angle this BPQ. Okay, what is this? BPQ. It is equal to TPQ. BPQ and TPQ is same. Why we are writing TPQ? Because here we have this TPQ. Okay, so TP, this one TPQ plus PQD, angle PQD means PQT is equal to 180 degree. Statement number 2, from given we have just changed the name which are in the same line. Instead of BPQ we have taken TPQ. Okay, now from this 1 and 2 we can say these two angles are equal, and therefore angle PQT plus angle QPT. This is QPT, PQT, just copy this. Angle PTQ is equal to angle TPQ. Let's write it as QPT. Just write QPT. Okay. First and third letter we can change, Q and T, not in between. QPT we have changed because to get the same one. Is it plus angle PQT. So from 1 and 2. So now cancelling this 2, same side, PQT. So here we get, therefore angle PTQ is equal to 0 degree. Okay. Therefore lines PT and QT coincide. And if these two lines coincide, therefore lines AB and CD coincide. Okay, but this is contradictory with given. Okay, this is contradictory. Contradictory that AB and CD are distinct points. AB and CD are distinct lines. And as we have proved it's contradictory, afterwards you have to just write, therefore our assumption that AB and CD are not parallel is wrong. Therefore AB is parallel to CD is proved. Okay. So in this way we can prove that first test, interior angle test. Now as we have proved this interior angle test, now for the next two tests we can use this interior angle test. Let's see how we can use. So there we can use that our angles as a small letters. Okay, in previous when we have seen, when we have proved that properties of these angles. So let's rub this part and now let's prove the second test, which is called alternate angle test. Here the statement is, if pair of alternate angles formed by a transversal of two lines is congruent, then the two lines are parallel. Here two lines, say L, M, N. We want to show alternate angles. Say this is angle A and this is angle B. We will show this is congruent. Okay. So here these two theorems are easy to prove because we have now proved this the first theorem. So now given is what? Line N is a transversal of lines L and M such that alternate angles angle A is equal to angle B, and now we need to prove line L is parallel to line N. Okay, now as we have given these two are equal, let's take such one angle which can make an interior angle with angle B, or you can take it here also. Let's take angle C. Now C will make interior pair with B. If you take C here, it will make interior angle with A. Any one way we can take. And now what is given to us, that given A is equal to B. But now we know that angle A plus angle C is 180 degree because they are angles in the linear pair. Now substituting A as B, if we substitute A as B here, so angle B plus C is equal to 180 degree. So here we have proved that the interior angles are supplementary. If these interior angles are supplementary, then by interior angle test these two lines are parallel. That's it. So like this we have to do. So proof part, here we need not require any extra construction or the indirect method. Okay, so this is the way we are going to follow. So angle A is equal to angle B. Statement number 1, it is given. Now angle A plus angle C is equal to 180 degree. Statement number 2, angles in the linear pair. Okay, and now therefore from 1 we can say angle B plus angle C is equal to 180 degree from 1, and therefore as interior angles are supplementary, we can write that angle, therefore line L is parallel to line N. The reason is interior angle test. Okay, so this is the easier one, and this also can be asked in the exam. So here we have proved that statement of interior angle test. Now to prove corresponding angle test, everything will be as it is, only instead of here. Now here as we have taken these two are alternate, now here it is if pair of corresponding angles. So instead of these words alternate, here we have corresponding angles formed by a transversal of two lines congruent and the lines are parallel. So instead of here just A, you can take it this A over here. Okay, so this pair, so here it is, we can write L is line N is a transversal of lines L and M. Okay, and such that instead of here alternate angles, you have to just change the word. It is now corresponding angles A and B are equal. And now we have to prove L is parallel to M. Now proof part will be as it is. Now A and B is equal to, if they are two equal, given part. Now angle A plus C is 180 degree. As these are also angles in the linear pair, we get this line because of these two angles. And now replacing A as B is equal to, so B plus C is 180 from statement number 1. And here we have proved that interior angles are supplementary, hence the lines are parallel. That's it. So if we just change a word from alternate to correspond and the position of angle A, so from alternate to the correspond angle of B, we have got a proof of this third test. So here we have today seen how to prove these three tests for parallel lines. I hope you have understood these proofs, and if you have understood it properly, please give me your likes, and your comments are also valuable. And if you are not yet subscribed the channel, please subscribe. Thank you very much.